Okay, so we are going to learn what's called the HL postulate today, but we're going to start doing a warm-up, so if you can go ahead and work on that. One thing you need to know is I forgot to label this point here. It's point B is the intersection of those two lines. All right, so we know that angle SWT is congruent to angle STW, and then we know that angle BTW is congruent to angle BWT. Now, there's more than one way to do this proof, but I'm going to show you a method that takes only 6 steps. So when I did this, I saw these overlapping triangles on the bottom. And so I noticed that TW would be congruent to TW. And that's bireflexive. And then next, if I were to separate them out, you would see that then those two overlapping triangles on the bottom are going to be congruent by angle side angle. So triangle FTW is congruent to triangle KWT by angle side angle. Now, the pieces that I want to get out from those two triangles are FT and KW. And you want to double check and make sure those are actually segments that are sides of the triangles. So FT and KW are letters that are in my triangle correspondence, so I can do this. And our reason is CPCTC. Now, in step 5, because if I look at this isosceles triangle here, I can see that my base angles are congruent. And so that means that ST is going to be congruent to segment SW, because if the base angles of a triangle are congruent, then the sides opposite them are congruent. So that's a just some practice with one of the theorems from the prior lesson. Once we've said that ST is congruent to SW, we can now use subtraction. And we can say that segment SK is congruent to segment SF. So that's just a quick review of congruent triangles and the isosceles triangle theorems. Now, we're going to learn a postulate that is used to prove right triangles congruent. And it says that if the hypotenuse and one leg of two right triangles are congruent, then the triangles are congruent. So here's a picture of two triangles that are congruent by hypotenuse leg, or HL. You can see here's our right triangle. The side opposite it is called the hypotenuse, and the two hypotenuses of the right triangles are congruent. And then we have a set of legs, one from each triangle, that are congruent to each other. So these two triangles are congruent by HL. Now, could we say that these were congruent by side angle side? Do we even need HL? Well, actually we do, because if it were side angle side, it would be the two legs that were congruent. The right angle is not the included angle. So they can't be congruent by side, angle, side. This is a special case of side-side angle, where we said before that it wasn't a congruent postulate, which is going to be true in general, except in the case where we have a right triangle, in which case side-side angle actually works, but we don't call it side-side angle, we call it HL. And that's only for the right triangle, where you have a hypotenuse and a leg. Okay. So looking at these examples on the bottom, we'll start with this first one, and we're going to see if those two triangles are congruent, and then if they are, which postulate are they congruent by. So in this first pair, we do have some congruent triangles. And these are congruent. We have side, angle, side for this one, and side, angle, side. The angle, even though it's a right angle, is an included angle. So that makes these congruent by side, angle, side. This next one, take a look at it and decide if they're congruent or not. So these are congruent, are not congruent, because in this case we have side, side, angle, side, side, angle for both of these. This angle is not the included angle, nor is it a right angle, and so that means that the triangles are not congruent. Then take a look at the third one. Now, we can get this segment congruent by reflexive, and we do have right angles this time. So even though this would be considered side-side angle, because of the right angles, it switches, and we call this HL. So these triangles are congruent by hypotenuse, leg, or HL. So this is the only case of side-side angle that's going to guarantee congruent triangles. And so we have a different name for it. It's HL. So we're going to try using HL in some proofs. And one thing that's important is that before using HL in a proof, you must state that you have a right angle. Okay. It's not necessary to say that the right angles are congruent if you're using HL. If you were trying to use side angle side or angle side angle, then you do need to say right angles are congruent, but to use HL, you just need to say that you have right angles. So let's do this first proof. We know we have circle O. We know that YO is perpendicular to YX, and that ZO is perpendicular to ZX. So if segments are perpendicular, then they make right angles. So I'm going to write that as step 2 in my proof, that angle OYX and angle OZX are right angles. Because if perpendicular, then forms right angles. Now we're trying to get YX congruent to YZ. This is not an isosceles triangle. This is actually looks kind of like a kite. You can't use if base angles are congruent, then the sides are congruent, because it's not a triangle. So I'm going to start by making some triangles and adding in segment OX by the line postulate, or 2 points determine a line, whichever you prefer to write. Then in step 4, I see I've got some right angles. Now, I know all radii of a circle are congruent, and I know any segment is congruent to itself. So if I look at this picture, it's not side angle side. This is an example of a place where we could use the hypotenuse leg postulate. So that's what we're going to do. So we have our right angles. That's the first thing we need to use the HL postulate. Then we need to make sure that we have the hypotenuse congruent, so OX is congruent to OX by reflexive. And then we know that OY is congruent to OZ because all radii of the same circle are congruent. And those are legs of these right triangles. So now we can say that triangle OYX is congruent to triangle OZX. And the reason is HL. So notice I did not use a step to say that angle OYX and angle OZX are congruent. You don't need to use HL. So then finally in step 7, we can say that YX is congruent to ZX by CPCTC. All right, then our last proof. So making sure we mark up our diagram. All right, we know that BC is going to be perpendicular to AC. We know that BD is going to be perpendicular to AD. And we know that AC and AD are congruent. So this proof looks a lot like the last one. Why don't you go ahead and try that? So going ahead and finishing up this proof, we would say that angle ACB and angle ADB are right angles. Because if perpendicular, then forms right angles. So I have some right angles. Now, my hypotenuse is congruent to itself in each of the triangles because it's the same segment. So I get my hypotenuse AB congruent to AB by the reflexive property. Then in step 4, we already knew that AC was congruent to AD. That's our leg. So we can go ahead and say that triangle ACB is congruent to triangle ADB by HL. Now our goal is to prove that ray AB bisects angle CAD. So here's angle CAD. So then that means that what we need to get out as congruent are those two angles. And we'll do that using CPCTC. We'll say that angle CAB is congruent to angle DAB by CPCTC. And then in step 6, we can say that ray AB bisects angle CAD. So finishing this off, the reason is if divides into two congruent angles, then the ray bisects the angle. Okay. And that's it for our HL postulate.